And we are live on this Tech Tuesday.
Hey,
I know, right?
it is going to take off.
Yes, indeed. Yes, indeed. How are you doing today, Angela?
I'm doing fabulous. I'm glad to be here. How are you doing?
I'm doing very well. I had a busy weekend, and I'm glad to just kind of cruise into this
I
week
love it.
and talk tech, talk AWS Lambda, and
Hey,
all the wonderful things that it provides. Yep.
so you're celebrating Tech Tuesday as well.
I
Yes.
am. I'm all up in this code.
I love it. Yeah, I'm not sure what made as I was typing out my LinkedIn message, it just felt like this feels like a momentous occasion. Why aren't we celebrating?
Yeah, yeah. Tech Tuesday all day.
All right now. Well, we picked a perfect day. The weather here, I'm sure where you are, is beautiful. It's not
Well,
not too bad. Really?
yes, you got to know, like Southern California,
But it
May
never
and
rains
June.
there.
Well, you know what? If you look outside, you would be hesitant. You'd be like, today might be that day.
Okay.
But what happens is in May and June, we have this, well, June, I guess more so, they call it June gloom, where
June.
the skies are just kind of gray and cloudy. And I mean, you might get a couple hours of sun
Okay.
because close to the ocean, you'll get this thing called the marine layer. The clouds just kind of roll in, they hang out till around noon. Sun comes out, it gets warmer, clouds roll back, so you get your 2 or 3 hours of sun. And
Hmm.
then as the day cools off, these clouds come right back in. Yeah,
Okay.
June gloom. So we can't get around it. I know
Interesting.
it's just now going into May, but we get the June gloom even early as May. So
I see that. Okay. Well, one to grow on because I didn't know that. I just
yeah.
assumed, it's always beautiful where you are.
Well, and that's what we tell everybody. So we'll just run with that.
Yes.
Cool, cool.
So I'm glad you had a wonderful weekend. Hopefully, you had a more restful Tech Tuesday, not filled with as many fun times and activities, but more of Lambda.
Yeah, I was going back and forth with Lambda today, and we can get
Okay.
into it as we get into the demos and discussions. But yeah, definitely a good day to talk about. What are we talking about? Today is Chapter 8,
Mm,
Advanced AWS Lambda. And for as short a chapter as this was, there was a lot packed into it. And I was
it
like,
was.
wow.
You really
Yeah.
had to focus and read and internalize. It wasn't, you know, as short as 6 and 7. It was a little bit longer, but it was so much content. Hence
Yeah.
the name Advanced AWS Lambda is the chapter name. It was a lot. It multiple topics, but I'm assuming they're all more advanced topics. When you
Yeah.
get past the hello world of it all, it's much more to it. So the beginning of the chapter starts with error handling strategies and
Mhm.
how to configure them, which was a very important chapter. Scalability,
Mhm.
this serverless service, its ability to scale is one of its features. Versioning and aliases, that was a huge uh part of it, where I don't know if this is something that folks use in the real world often,
Mhm.
but it is a nice feature to have.
Yeah.
Cold starting, that was another, you know how you start your car with your electronic doohickey and you put your coat on and grab your purse. Well, you don't. And when you get out there, it's like, oh, my car's warm. This is so you can do that with Lambda. I That was
Yeah.
my analogy for for a
No,
cold
no, I
start.
can dig it.
And then when we think about serverless, we, it states something you really think about. Like sometimes,
Mm.
your code can kind of hold on to some state, but sometimes you need persistence, depending on
Mhm.
what your function is doing. Lambda can cache information to be used in later iterations, but is that, how you should be using it? There was another section about the Lambda and a VPC, which is
Mhm.
now stepping into the realm that I totally understand. It's like, oh,
Okay.
well, you just need an endpoint. There you go. You can
Yeah.
you can have your Lambda work there. Something about layers and runtimes, that
Mhm.
a lot of new a lot of new information. I think a lot of good information if you're ever working in Lambda, no matter the language. Again, very Java focused. They talked a lot about Java. They talked about WebSphere. They talked about JBoss. They talked about Spring and Spring Boot. Shout out to Shad at Red Hat, who actually does courses. I want to say on Udemy on Spring and Spring Boot. He is
Cool.
I know a lot of smart people. Oh my God.
Mhm.
You're the LinkedIn DevOps person, and he is the Java person, Spring and Spring Boot on that learning
Cool.
platform. So, yeah. So let's get into it. That was my
Yeah.
overview. That was
No, and I appreciate that because I was just sitting over here nodding my head like, yep, That's exactly what it was.
awesome
But yeah,
sauce.
and reading through this, I thought about how these are all important topics for Lambda and how to apply them. And maybe they call them advanced because, or maybe I don't know, maybe advanced is it might be a misnomer. I don't know.
I think
But
so. I think so.
but I think it was topics that they wanted to capture, but they maybe didn't want to spend so much time on them that they dedicated a whole chapter to error handling, a whole chapter to scaling, or whatever the case is. So they just kind of got all these topics together, gave them their due diligence, and then called it advanced and put it into this chapter. But
It's
let's
I was going to say it's definitely past Hello World.
yes, yeah. And oddly enough, all of my demos are Hello World.
That's okay. It's
Yeah,
okay, but you can use that
yeah,
as a gateway to these other topics.
for the demonstration. So yeah, jumping right into error handling. I seem like we touched on this every single episode of this. Well, maybe not, but a lot. Synchronous versus asynchronous.
Yes,
and how the calls are made and how you need to handle these errors. Whether you're handling them in the function or you're passing it back to API gateway, if that's the way the function is called, and letting API gateway handle it, or if you're doing, some other way of handling it, if you're interacting with another service, for example, S3 or SNS and Kinesis, those were some of the examples that they gave. So there's a lot of different ways that you can handle these errors. And we'll get to the demo maybe after the discussion, but I've ran into some problems with this, like wanting to handle the error in Lambda, but finding that the way that I did that kind of made the request look funky on the API gateway side. So, yeah, it's important to, I guess, to understand the integration between the two. And just kind of briefly, and I'll get more into it in the demonstration, I was trying to throw an exception so that I can observe an error in the way that error was handled. And I was definitely throwing errors left and right in my function, but API gateway was saying 200. Okay, everything's good. And I'm like, what are you talking about, API gateway? It's like the function is failing. But because I was actually handling the error inside the function, API gateway,
it was like, it looks good to me.
It didn't care. Yeah, it was like, I called this function, the function performed, and it returned. And so I'm going to tell the client that everything is great. And so it returned to 200. And I had to actually do some crazy, funky code just to get it to fail all the way through the pipeline back up to API gateway to show
that's going to be a good one.
Yeah, the 500. So yeah, error handling, that was fun.
All right. Well, you're right about the various behaviors of Lambda processing. You mentioned it: synchronous, asynchronous, and streaming queue. And then in the book, it does give you different ways to handle, or suggestions on how you should handle them in your code. So when we talk about configuring error handling, think of it as rules for when something breaks. You know something's going to go wrong. You just want to prepare for it in the best way possible. So by default, it says AWS retries failed invocations. In synchronous, it'll do it, return an error to the caller with no retries, zero retries. And then the asynchronous way, like from, say, S3 or Event Bridge, it'll automatically retry twice with delays. And then there's something called dead letter queue. That's used. I've used that before, but for Lambda, it'll forward events that fail to the dead letter queue, and then you can process them. Once the event is in SNS or SQS, you can do whatever you want to either handle it immediately or manually. So it gives you some kind of grace, a little bit of grace there. And there's a SAM template, again, all Java all the time in this chapter, but on page 188, it talks about using your SAM template and configuring your dead letter queue and dead letter queue listener. So if you're reading the book, definitely check out page 188 on how to handle those type of errors. And I think it does a really good job of explaining it. Again, very Java focused, but yeah, should be pretty good.
Cool. All right.
All right. What's
Next up was tracing errors with X-Ray. And
yes.
this kind of goes into some error handling strategies as well. And honestly, I mean, I hate to keep putting a pin in it and say we'll come back to it, but all of the couple demos that I have, they cover error handling, X-Ray, even logging and metrics going back to the last episode, you know, stuff that I didn't get to in the last time. I actually got to it inadvertently in my demos for this particular discussion. So I'll be able to show some of that as well. So
this is basically your capstone project. You have really incorporated all the things.
Exactly. And they didn't spend too much time on X-Ray, a few pages.
2 sentences.
Yeah. But I mean, the demonstration to see it in action is actually cooler, I think, than talking about it.
All right.
So I'll like I said, I'll put a pin in that and we'll come back to X-rays. And I mean, unless you had any thoughts, I was just going to go right on to scaling.
Go to scaling. Okay. That's definitely a very very meaty topic inside of the chapter. So yeah, let's talk about that.
Yeah. So I mean, that scaling is one of Lambda's like best features, right? That's kind of the go-to, because you get basically load balanced horizontal scaling without having to do anything, because Lambda will automatically create more instances of your function as needed to handle all the requests that are coming in. So you definitely get the benefit of that. And the example that they gave, again, Java specific. So I actually did use Java code this time around. I put my Python on the shelf for this particular example. Again, putting a pin in it, but we'll get to it in a minute. But the one cool thing about this is when Java has static variables or properties in their classes, they're reused across function instances if Lambda can reuse them.
Right.
So we'll see how like you might be calling a function very regularly, and it's basically on the back end, Lambda is reusing that function, because I mean, kind of getting ahead of ourselves for as far as cold starts, but that function is warm, right? And the information is loaded. So Lambda's like, yo, I'm just going to pull data from here and I'm going to reuse it because this function actually needs it again. And so I've got a demonstration that kind of shows how that comes together as well. I thought that was kind of cool.
I agree. So Lambda scaling, we've put a pin in it, but we can talk about it a little bit. I think you pretty much hit all the salient points. Let's see.
I didn't get into like the burst limits, reserve concurrency.
That was a
threads. Lot. Yeah. That I guess that was going more into threads in particular. You know, thread handling in Java.
There was a whole section on that.
Get into a discussion about that.
There was a whole section on Lambda and threading. Let's see. What can we pull out of this bad boy? I'm looking at my let's see what we got here. Oh, so like you mentioned, like it's almost like if a function runs a lot, it's kind of waiting in the wings. It has a warm start for the next invocation of it. That is key to Lambda's scaling model. If all current instances of a function are currently in use when a new event occurs, then Lambda will automatically create a new instance to scale out. That's the scaling part of it. And after a period of inactivity, just like when you scale up your auto scaling group, after a certain amount of time, it will scale out or reap the function. It'll clean it up. and because of money matters, this is one of the things that when you're worried about cost, it says here it costs the same to process 100 Lambda events serially in one function instance as it does to process them in parallel. So then this alludes to cold starting, which we'll talk about. Lambda has scaling limits, as do most AWS services. It didn't say what it was, but I'm going to assume, like with most services, you can probably reach out to them to get your limits increased to some number, I'm assuming. Yeah. Let's see. That's all I have for scaling.
Okay. No, and that's good enough for me, man. So we can move on to versions and aliases.
New topic for me
yeah.
in Lambda. I mean, it exists outside of Lambda. It's interesting that this tool, this service, utilizes that functionality as well, and pretty much the same way too.
Yeah, and I mean, and just to kind of review, basically, and pardon me for hacking all over
You're all right. You're all right.
your eardrums,
You
dear
good.
listener and viewer. But basically, you can have the same function, but different versions of it or different ways to refer to it. So that's what these versions and aliases, kind of allude to. And so you can have different paths or different means for invoking the function using version 0, version 1, so on and so forth. If you don't do anything along those lines as far as versions go, Lambda is just going to use this designator called latest. So whatever code was deployed last, that's what you're going to get if you call the function and you don't have any other versions defined. As far as aliases go, then you can and it's saying here, alias is a named pointer to a Lambda version. So it's either that latest pointer or a numeric snapshotted version. So you can have different aliases that point to different versions of your function. And I mean, I see how this is useful if you want to, I don't know, and this is where I get kind of, I have my own biases and opinions on this. But if you want to deploy code into the same slot where your function lives and refer to it using these different aliases and versions and so on and so forth, you can do that. But I think then you run into problems, particularly if you are a inexperienced or a lazy developer or operator, then you could be blowing away good code that people are actually using. The intent for this is to have, say, like a staging version or a test version, so people can try this out, try the function out, see if it works with their stuff, and then if it does, then maybe move that version into the production slot. But what I found is a better approach is to have two separate functions with the same code. So that way, if you're deploying to the staging environment, you know that you're deploying to the staging environment. Do all the testing that you want there with this latest version, this latest alias. Once everything looks good, then you can roll everything over to the production environment, the production function, and everything works there. And the crazy thing about them going into detail or even mentioning versions and aliases, I guess they got to mention it because it's a feature, is that the authors even suggest not using versions and aliases.
Exactly.
On page 101. They actually say.
Did you notice there was a lot of cautionary stories? Don't do it.
Yes.
You can do it, but don't do it. And this was another one of those examples. Just because you can doesn't mean you should. You should always have a really good use case for trying to do something that actually gives you more complexity to deal with. There was one thing about after the Lambda versions, the Lambda aliases, there was something called traffic shifting, which we know exists in this world, where you can send some of your traffic to a new version to test it out, canary testing, things of that nature. So that's another use case. But again, shifting traffic to where your functions are, if you do what most developers tend to do, is what you said. It's the same function. It lives in, it's for two different development environments. That's the safer way to use it. You're not really keeping track in that fashion. But yeah. Uses
Yeah.
some.
One comment I had with traffic shifting, I totally see the need and importance of using all these different methods they use, all at once, canary, linear, and some custom thing that you define yourself.
Yeah.
However, I feel like you can still do that at the environment level where you have different versions of your function and handle it at the API gateway with some traffic shifting there. I don't think they really went into how you could do it at. Oh, they said code deploy. So they're saying use
Mhm.
code deploy to manage this traffic shifting, which is totally good for.
Yep.
But and I guess the point that I was getting at, if you just got this little onesie twosie function that's running, you probably don't have to worry about canary or linear or custom. Just do it all at once and you're going to be fine. The next time you call that function, guess what? You're going to get the new stuff, right? But if you're somebody or an enterprise, a service provider or something, and you have dozens of hundreds of thousands, maybe millions of clients that depend on a particular version of a function or some route, and you're deprecating that particular version, then maybe you want to have something that migrates them over to another version of that. But even then, a lot of times, when like in terms of APIs, we'll have services that say, okay, this is example.com/API/v0, and you're on v0 as long as you're using that. Well, guess what? When we update this API, we're going to have example.com/API/v1. You got to update your code to point to v1. We're not going to be changing the alias for you because we're not going to force a potentially breaking change
Right.
on you. You got to do that yourself. So yeah, versions, aliases, traffic shifting, very interesting. And there's a lot of different ways you can handle it. And again, I'll put my biases to rest. I won't rehash all of my thoughts on that one, but
No
I'm
worries.
glad they discussed it.
Well, again, it's the functionality does exist, and if you have a use case for any of the stuff that is mentioned in this
It's there.
chapter, by all means, you should utilize it, but test but verify, because
Hmm.
they also said in the book that sometimes it doesn't buy you what you think it buys you, specifically for cold starts. It's which I hope we're segueing into with this little aside here, but um it they even say that this is probably not the best way to if you're looking to have your environments start faster.
Hmm.
Yeah, it we're going to talk about cold starts now, but again, this was one of those topics where they say most use cases don't really need this, and
Yeah.
the problem is really not with how fast things are starting. It could be within your code. So a lot of caveats in a lot of the topics that were discussed in chapter 8. So your use, what does it say? Your mileage may vary.
Hmm.
Okay.
Yes, indeed. All right, moving right on to cold starts. This is the I think it was funny that they say I forget what the comment they had, but basically they were saying like some people say this is the feature that'll make or break your your use of Lambda, right? If you got to worry about cold starts. And I wonder if in the 4 or 5 years, or maybe even 6, depending on when they started developing this book, if Lambda has improved to the point where cold start isn't even. I mean, it's always going to be
Interesting.
a concern, but AWS is continuously working to have these Lambda runtimes start as fast as possible.
Yep.
So within 5 years, have they made improvements such that this cold start time has gone down from however many milliseconds it was 5 years ago to maybe tenths of that or even hundredths of that. So
Hmm.
maybe we do get a cold start, but maybe we don't even realize it because the function executes so quickly.
Right. That's interesting. It would it would be nice. I'm about to go to the AWS website and find out what they're saying about cold starts. But like you
Sure.
said, this book was a point in time, maybe 5 or 6 years ago when they first started developing it. And we know AWS is always, it's either going to
Mhm.
get rid of it or it's going to improve it. Every time you turn around, reinvent, rah, you're going to get, all the new hotness. You're going to get, when you're following their RSS feed, you're going to be getting all of the improvements that they make even throughout the year. So that's interesting. I am going to go to the documentation and see what's what.
Okay.
Now,
Well, I mean, while you're looking at, I had more thoughts on cold. Well, I mean, the bad thing about cold starts, folks, is if you do have a function that has a lot of requirements, a lot of dependencies that it has to load, it puts more pressure on Lambda to build out this compute environment to actually run your function. Then it's going to slow down responses.
yes.
So if you have some synchronous API, some function that has to return a response, and somebody's sitting there waiting on it, and they're waiting for your function to start before it even does anything. So locally, you're testing, you're running, and everything's great. You deploy that Lambda function, and guess what? You've got a 3-second response time, 2 seconds response time, and people are like later for your hello world.
Exactly.
I'm going to do hello world with somebody else over here. So that's the whole reason of having either minimizing, eliminating, or reducing cold starts.
It does say I'm reading in the Lambda developer guide that cold starts typically occur in under 1% of invocations. So I'm going to assume they're more common in development and test than they are in production workloads. It says that. So this is because development and test functions are usually invoked less frequently. So having them ready for when it needs to happen, you're probably not going to lose any money that way. But for production, to have that level of latency is not acceptable. So yeah. And then, of course, the documentation goes into the next topic. We're not going to skip cold starts, but the documentation goes into provision concurrency and static initialization. And so you're right. The documentation, I say this all the time. So say if you're studying for AWS exam, and this is a quick aside, and you're reading this book or taking this course from a point in time. Well, we know these cloud vendors are like always making improvements. It is always best to go to the documentation, to the frequently asked questions to see what has changed. There is going to have been changes, especially for more of the more popular services. They're always making improvements. So it's better to have the latest and greatest information at your disposal than relying on something that was written or course produced 2 or 3 years ago. So just a little tip there. Always,
that's a gem right there.
Yeah, always check the source. All right.
So just a couple quick notes on preventing cold starts. And I'm glad you mentioned production use or whatever. Number one, even if it's testing or whatever, keep your code lean. So minimize your dependencies. That way you get fast starts, out of the gate. And then you mentioned provision concurrency, which is basically you're telling AWS, hey, keep some of my functions warm and ready to go. So that way, they're just sitting there. They're like, chomping at the bit, ready to process these requests. The upside is, you won't have cold starts. The downside is you're paying for those functions to be sitting there waiting. And if you don't have the requests that are coming in, it's essentially a waste of money, in my opinion. So the flip side of that is if your service is popular enough, or whatever you're doing with these functions, that you're getting many requests, your functions are going to be warm already. I mean, we talked about how Lambda will hold on to, some of the data that the functions have used when it builds out these compute environments. And so everything's warm. You don't have to provision concurrency. If your service gets busy, maybe those first couple requests are slow, but then everything else scales up. It's running, like clockwork.
Yes.
And then when everything is over, that big spike or whatever, everything goes back down to zero, and you're not spending money unnecessarily on these functions that are just sitting there waiting to do something when there's no traffic coming in. So toss up between provision concurrency and how much money you got in the bank.
Exactly. All right. Well, I think it's time for a demo.
should go to a demo because I'm looking at the time. I don't want to go
Same
over
things.
and I don't want to bore our dear listeners and watchers and viewers. Real quickly though, they went on to talk about state. Lambdas don't
Yes,
hold state. Use DynamoDB, RDS, S3, or Elasticache. Basically, store your data somewhere else.
there you go.
They talked about VPCs, adding using VPCs to connect your functions to stuff running inside your virtual private clouds. Layers where you can have different slices basically of your functions sitting in Lambda ready to go. And then custom runtimes. I mean, they already give you Node, they give you Python, they give you Java, they give you Ruby. But if you, I think you got Docker too. But if you get something outside of that, you can build your own custom runtime and Lambda will handle it for you.
Okay, we're getting ready to go into a demo, but I have a note in the margins, and I have to tell you this. So caching, you really don't have, but it says here, we have no guarantee that one Lambda function instance will be called multiple times. We do know that it probably will be, depending on the invocation frequency. There's really no guarantee. Now, like you said, if it's being invoked enough, that information is already there. It's already warm. It doesn't need that long start time. There is no guarantee. Like Chico DeBarge and Joe. And I just saw Joe last weekend, and it's like he didn't sing that song because I guess it's not his song. It's Chico DeBarge's song. I was so upset, but no guarantee. That caching in Lambda, no guarantee.
Yeah. So yeah, if you want to guarantee that you're preserving your state, you got to go with DynamoDB.
There you go. There you go.
Go with a database, Elasticache. Put it in an S3 bucket. Just
anywhere.
Stick it somewhere. Oh, and the other thing they didn't mention too, but I think is a new feature for new is relative. I can't remember when they introduced this, but I believe you can also mount elastic file systems or EFS file shares to your Lambda function.
Really?
So that's just another option for
it makes sense though.
Saving your data. Yeah, exactly. So
awesome.
No way, but thank you for that little buffer there, because usually when I go into demo mode, I gotta mess my screens around and everything, but I am ready to go into the demo. Before I do that, let's get this off the screen, and I will show the URL for our GitHub repository. If you want to take a look at this code, go to github.com/cover2code, and there's a directory in there for season 2. And even more specifically, if you go into the season 2 directory, there is a chapter 8 directory that has all of these particular demos in it, or the code for these demos. 2 Java, 1 Python, but it really doesn't matter if you're just kind of looking at the way that the stuff runs, right? Okay, the stuff that we put pins in, we talked about error handling, X-ray tracing, scaling, and I'm even going to touch on cold starts as well. So really quickly jumping right into it. This is the X-ray screen in CloudWatch. So if you're on the CloudWatch menu, it's this X-ray traces option over here on the left. And basically I can see traces that were collected from functions that ran over some period of time. And the way that I set this function up, I just randomly flip a coin and say, every other request or so, give me a fault, give me some sort of 500 error. Otherwise, it's going to be okay. So I'm tracing all of these executions, and then some of them are fail, some of them are pass. So that's why we see here under trace status, some of these are giving false, some of these are giving okay. And if I go into the details of this, we can trace the request from the client through API gateway and through how the Lambda context is put together, and then how the function processes that in response. So this is the trace here. Ideally, all of these things would be green. That means everything's good all the way down, which is, and if you scroll a little bit further down, it gives you more detail on how everything ran. I'm not sure where this 400 error is coming from, because everything says it's okay. That's something I'm going to look into maybe down the road just to kind of figure that out. But this was supposed to be one of the good responses, right? This should be green from front to back. Everything's great. But I do have some sort of funky thing there. We do get logs. Going back to last episode, last discussion, I'm using JSON logs so I can get all the good data. And we get some additional detail with this particular type of response. And look at this right here. They tell us if this was a cold start or not. So in this case, this wasn't a cold start. So cold start equals 0 means it wasn't a cold start. It's a function that was, already sort of warmed, and it was able to process it again from a previous execution. So that's one way to see if your function is a cold start, to look at the context output from your trace in this particular case. And I'll pause there in case you got any questions, comments, or anything before I go to the next one.
I'm ready.
Which is another X-Ray demo.
Okay.
So this particular X-ray is showing a fail. And I mean, we see this big red, circle right here. This is the API gateway, and it's actually surfacing the error here in this spot, right? So we see, the client's going to sending their request in. It's going all the way back to the function, and then the API gateway is surfacing the 500 error. And I mean, if you were with us at the beginning of the discussion, I was having some trouble getting this to work the way that I thought it should work, because I was handling the error in the Lambda function, but API gateway was saying everything was okay. And I didn't think that was right. So I had to actually put a fake, some sort of fake function call just to really break my code to get the 500 error to come all the way up to the top. So we see up here at the API gateway stage, it sees the 500 error. All the way back here is where I injected the error. And if I go to, I think I got the logs on the next screen, but well, let me go here and see what these logs are. Yes, this is for the error. And I'm saying, hey, error mode is selected, because I wanted to know, when I was injecting the error as opposed to some other error. But if you want to see what the actual error was, no, that's a good response there. Oh, and going back to last episode, I was actually collecting metrics too. So I don't think I have a tab up for that, but I'm counting the cold starts of my function. I'm counting the executions of my function. So that was kind of cool to actually get that information. But let's see, here's a warning from Lambda saying I had an unhandled exception because I wanted to pass this error all the way back up to the front to API gateway. So I didn't even touch it. I was like, what you're going to do is you're going to get this error and you're going to say 500. But I wanted to see, oh yeah. So I was throwing all these different kind of function names in here, and basically I was causing the error because I'm putting bad code in there. And I'm using this library or this function API gateway resolver, and it's an object, but I'm putting fake attributes on it. So that's what's causing the error in that spot. Okay, so I think that wraps up for error handling X-Ray. A little bit of cold start. Let's go into now
scaling.
Scaling, yes, indeed.
Okay.
So in this case, I've got some functions that I just run in a couple different ways. And this one, I have one instance of a client, for lack of a better term, that's going to be calling this function, hello world function, that returns the ID of the function that processed the request. That's all it does. So I got one client sending about one request per second in this particular case. So the thing that you notice in this case is that the ID is Java 45. So, and I'll make that a little bit bigger so everybody that's watching this on their mobiles can see this stuff, right? So the ID is the same, even though I'm sending, you can see the time changing over here. I'm getting about one, maybe two requests per second. But Lambda on the back end is handling all these requests with the same instance of the function. So that's just, it's keeping the function warm and it's reusing this execution environment that it's created, right? So everything's is going pretty good there.
Okay.
But what if we have, let me get out of here. What if we, actually, I'm going to leave this guy running just for sake of the next part, because I think I reuse this particular function. What if we have multiple clients that are requesting the same thing? So in this case, I've got 4 sessions, 4 terminals where I'm going to run this command that sends requests to the Lambda function. So I got the one thing still running. It's giving me 1 to 2 requests per second. I'm going to add another 4. So in total, I'm going to be getting maybe 10 or 12 requests per second, something like
Okay.
that. So let's see what happens here. And I'll try to make this a little bit bigger. Oops.
We might see some differences.
You're going to see, I'm pressing the wrong key trying to make this bigger. So what you'll notice,
look at there,
is on the back end, what Lambda is doing is instantiating new or creating new instances of the function. So you see some of these, the IDs are basically changing. I still see 45 popping up every now and then. So that one's still out there processing stuff. That's the one that we had in the last window.
right?
But I'm seeing some other IDs here too, like 16, 78. Look to see if I see any other ones. So it might just be 3 functions, really. I see 16, 78, and 45. Also, I see 43. So
Okay.
that's 4 instances.
I think that might be 16. You said, yeah, I think that might be it.
I think that's about it. Yeah. So it's scaled out from the single instance that we had before with the one client sending 1 or 2 requests per second to about 4, maybe 5 instances handling 5 clients, sending 1 to 2 requests per second.
Nice way to scale.
I know I did.
And you don't have to do anything to make it scale, which is
did not
amazing.
have to do anything. Yeah. The cool thing about this, and I mean, we can see this because I'm using Java specifically, and it has the static class in it for the ID itself, and it's reusing that per instance of the function. You might not see the same behavior with Python, which is more what do I want to say, like dynamic. It's gonna create everything as soon as the function starts up and gets executed. You're going to see different numbers every time. So you may not see the same behavior. You're still getting the same sort of warmth on the back end from Lambda, for lack of a better term, but you may not see it exhibited in this particular way.
All right. Was there anything else? I think you checked all the boxes about what you wanted to share in this conversation.
I think so. See, error handling, X-Ray, scaling, cold starts. I didn't do any demos for state layers, custom runtime, VPCs.
That's okay. But we talked about it.
And I will say, for state though, the weather, and I totally thought I was going to break out the weather API for this particular discussion, but go back to the last episode, look at the weather API. It uses DynamoDB to preserve the state of those Lambda functions, or the weather that gets written into the API.
Nice. Well, this was a very lively and in-depth discussion. I don't think we've ever gone this deep into a chapter, but I think because they're calling it advanced Lambda, it just introduced so many new topics in one chapter that we really felt that we should address them all. And who knows? I mean, we're coming up to the end of the book.
Coming up to the end.
What is chapter 9 or chapter?
Yeah, chapter 9 is advanced serverless architecture.
Okay.
And if we stay to our schedule, we're going to go ahead and include chapter 10 as well, which is the conclusion. And just kind of wrap things up there.
All right. Well, if you are listening, if you're listening live, reach out to us and let us know. If you're on YouTube, comment what book we should read next. We're taking all suggestions. If you're on LinkedIn, definitely hit us up in the chat. Reach out to us on our socials. We need to know what's in the next season. I mean, so far we have a pretty good streak. We are being consistent. We are reading these technology books and learning a lot of stuff along the way. I know I am. So
yeah, no doubt.
So I think last week, did I talk about DevOps days?
You did. You mentioned you got your book signed. You got another book.
Yes.
And they talked about testing as well.
Yes. Okay. I checked that box. I will not bring it up again. Oh, I went to another tech meetup last week. I totally forgot.
Awesome.
I totally forgot about it. I went to a Red Hat
Mhm.
user group in Charlotte, North Carolina. If you are anywhere in the US, I think they have them overseas too, but check your city and see if these meetups are out there. There's the Red Hat user groups talking about all things Red Hat. This week it just so happened to have been ACS, Advanced Cluster Management, but it's an image mode, which is the new hotness. It's not even new, but we're talking about it a lot in RHEL, where you're using images like containers, but they're literally, you're spinning up VM instances in the cloud,
Mm.
on-prem, bare metal. So get some tech goodness in your neck of the woods. Find a meetup, join it today. Keep that learning going, because we live in strange times. You never know when you need to,
Yeah.
reach out to someone who works somewhere and ask for a referral. So keep your network wide and keep it open.
No doubt. No doubt.
Yeah. So that's it
Um,
from me.
yeah. Well, catch us in the chat, catch us online. You know where to find us.
Yes.
Let us know what you're reading. Let us know what we should consider for our next season. And yeah, we'll take it from there. So thanks for joining us live. Thanks for listening and tuning in afterwards. And we will see you soon.
See you soon.